So this video is a really quick tutorial about how do you program any analog in sensor using CircuitPython. I'm going to be using an analog line sensor in this tutorial, but realistically you can use any analog sensor for this. It'll all work. This video is going to be in 3 parts. I'm going to show you how to wire up any sort of analog sensor. Then I'll show you how to actually just read the value simply. We'll go into another level of abstraction as to how do you read the actual true voltage that an analog sensor is going to get into. And then we'll get into one more level of abstraction using a map range function so we can actually give ourselves a realistic value. Okay, so once you've got your analog sensor, for this tutorial I'm going to be using analog line sensor. How an analog line sensor works is there are 2 LEDs at the end of this line sensor. And one of the infrared LEDs is casting a light out, and one of the infrared LEDs is waiting for the light to come back in. So effectively it's bouncing a light out and it's waiting for it to bounce back in, and depending how long and how much light gets reflected back, we'll give a different value on this reading here. If a lot of light gets absorbed, it'll give you a really high rating. If a little amount of light gets absorbed, it's going to give you a really low rating. So I've just got a standard piece of paper here. I have just white, and then I've just taken a permanent marker and I've just colored in some black at this point. This line sensor works best when it's 3 to 5 millimeters away from the surface that you've done. So I've has a little 3D printed mount here that takes the 2 little infrared LEDs and it gives them the perfect amount of spacing to be about 3 millimeters away from the floor. So if you have this scraping on your table, you're going to have more success. I could take a female jumper cable and just direct it and wire this directly into our microbit if we wanted to. But for this, I've got a sensor cable here. That's basically a 3-pin female Dupont to 3-pin female Dupont. And then I'm going to plug this into my Servo Shroud to male jumper wires here. That makes life a little bit easier. So I'm going to go ahead and wire this in. And this sensor here likes 3.3 volts as its logic. With your microcontrollers, they can either use 5 or 3.3 volts. I'm using the M0 Express. This does prefer 3.3 volts in its sensor ports. It is 5 volt tolerant though, so we'll also accept 5 volt signal. So I'm going to take my signal pin here. I'm going to plug this into A0 for analog 0. And then I'm just going to plug my 3 volt into 3 volt here and my other part into ground. And that's it. So wiring is up. It's super simple. We can go ahead and plug our microcontroller in. And now we've got our board up and running. So let's head over to the computer. Let's talk a little bit about an analog versus a digital signal. In an analog versus digital signal, a digital signal is going to give you either 3 volts, 5 volts, whatever logic it is that you're using with, and 0 volts. It just gives you either or. There's no in between. An analog signal is actually going to give you a range of that. So it'll give you a continuous range between 0 and 5 volts. So how do we actually read these things in CircuitPython? First one, we're going to go through about 3 different ways here. The first is kind of the lowest resolution point. We're talking about reading in 16-bit resolution here. So I'll leave this GitHub link in the description below, so you can just copy and paste if you want. But if you'd like to follow along, the first thing we're going to do is we're going to import time. That just allows us to put in some sleep functions. We'll import board. Board is kind of what allows us to access all of our digital pins. And then we can either import analog in out, or in my preference, I say from analog in out, import analog in, because that's the only method we're going to be using from the analog I/O port here. Now we need to create our sensor. So for our sensor, this is going to be our analog in port. So I'm just going to call this one analog in sensor is equal to analog in at board.A0, because I plugged into A0. Of course, if you plugged into a different analog port, you can do so. And all we're going to do is we're just simply going to read whatever our analog value is, and then we're just going to print it out to our serial port. So while true, we're just going to simply print analog in sensor.value. And what this line here is going to do is analog in sensor.value is just going to grab whatever the current value is. So it's going to read our sensor. And then I'm just going to put in a time.sleep of a 0.1 just so that we have a little bit of sleep to kind of prevent some debouncing that'll happen. I found that if you don't put in a really minor sleep, I mean, you could even put in like 001, but if you don't put in a very, very minor sleep, it's going to have a tough time reading through its sensor. So if I go ahead and save this to our CircuitPython board, I already have code.py loaded up on my CircuitPy drive here. So as I save it, you can already see that my code's over here. And if we open up the serial port, we should see, let's try it one more time. Apparently I dipped into safe mode. I'm going to have to reset. And let's try that again. There we go. So now I'm starting to get my analog readings. So if I come over here to our board here, if I put it on white, you'll see we're reading about 16,000. And as I come over to black, you'll notice we get up to about 33,000. So quite a bit more light is being absorbed on black versus on white. You can also tell, let's see, if we put it on this more reflective surface, we get quite a bit more is being absorbed there. And if we cast these things up into the sky, you'll notice that we seem to almost peak out at our maximum value. So these things are quite sensitive to external light as well. So keeping that out. But the problem is, if you look at our serial port or serial readouts, we're getting about 63,000, we're getting about 19,000, we're getting about 31,000. Like, that's really hard to program in a 16-bit resolution, because a 16-bit resolution is, of course, going to be running through 0 and 6,535 or 65,536 values of ranges to go through. That's a bit of a nightmare to work with. So let's try a different level of abstraction, and we're going to start reading our true voltage values. So for our true voltage values, it's the same thing, but we're going to pass in a handy little sort of translation function here. So we're going to define get voltage, and we're going to get the true voltage from whatever this is, because an analog sensor is effectively sending a voltage back to the board. So we're going to try to figure out what that actual real voltage is. So we'll get voltage, and it requires a pin as an argument. And then in this case, we're going to be using 3.3 volts. So we're going to just simply return the pin.value multiplied by our voltage. In this case, we're using 3.3 volts. But if you're using a 5-volt system, you'd probably want to replace this with 5. But I'm using 3.3, and they're going to divide it by 65,536. So now, inside of a while true loop, rather than just grabbing the absolute value, what we're going to do is we are going to say print get voltage, and then as our argument, we're going to use the analog in sensor. So now if we were to save this and we look at our serial ports, now we're starting to get the actual true voltage output. So right now, as I bring this down, we can actually see that our analog line sensor is sending about 0.9 volts back to our system. If I bring it over here, we're sending about 1.5 volts. And if I look up in the sky, we're sending about 2.9. If I were to bring an external light source and cast it onto this, I'd get an even higher light voltage. But again, working with voltages can be kind of challenging. So let's make our own custom range here by using a mapped range instead. So what I'm going to do is I'm going to use just an Adafruit library here. So I'm going to say from Adafruit underscore simple math import map range. Now, in order for this to work, you do have time, board, and analog I/O already baked into your Metro Express, and likely you do already have one baked into your CircuitPython controller. But in order for you to be able to use simple math, you have to make sure that in your lib folder of your CircuitPy that you do have Adafruit underscore simple math as a MicroPython library. If you don't have one of these, I'll leave the link to be able to find that in the description below, out on that GitHub as well. So now when we start playing around with this, here's what we're going to do. We're going to change our function up a bit, and instead we're going to say define read analog sensor. Again, we're also going to take a pin as an argument, and we're simply going to return a map underscore range, which is this one here. And map range takes 5 different arguments. Okay? The first argument it takes is the value to change. The second argument that it takes is the old minimum and the old maximum. And then it'll also take the new min and the new max. So inside this map range, the value we're going to read is going to be our analog sensor.value, because we need to actually grab the current value. So that's what's actually going to read it. Our old minimum is 0, and our old maximum is 65,536 for that 16 bits of resolution. And then you can really choose any sort of range that you want here. I'm going to choose between 0 and 100. You could choose between 0 and 10. You could choose between 0 and 1,000. And what I'm just going to choose between 0 and 100, because 100 bits of value it's a pretty good range to work with. It's also a nice kind of human range to work with. And what this is going to do is it's going to take this number 0, and it's going to translate whatever numbers in between here into this point. So if we were to take, 65,536 divided by 2, I think that gives you somewhere in the ballpark of 32,000, something like that. But if you took the exact midpoint of this, the exact midpoint here would be about 50. And if I were to read the highest value possible, 65,536, I would end up giving 100 back as my value here. So that's all map range does, is effectively takes an old range of values and maps it to a new range of values. Just to make it a little more easy. So now, inside of our print statement, we're just going to, rather than saying print get voltage, we're going to say read analog sensor, and we have the same analog in sensor as our argument, because this is our sensor here. So now if I were to save this over and open up the serial port, you'll notice that we're going to have a much more, save it over please. Okay, oh. I've got an incompatible MicroPython file. So this is good, because I apparently have the bad one. I've got a CircuitPython 8 board in here. So let's actually grab the correct one on. So I'm going to go over to my CircuitPy, go to my lib folder. I'll come over to my downloads, and I will grab the new Adafruit Simple Math, pop it inside, give it a replace. So if that ever pops up, likely you just have an old MicroPython file. My CircuitPython changes a lot. So I actually had a CircuitPython 8 Simple Math library on, and I needed an Adafruit 9's version. So now, if we look at our serial output, I've got 80 as my range here. And if I put onto white, I've now got 32. If I come into black, I've now got 47. And I am getting a decimal value here. So it's up to you whether you like these decimal values or not. If you'd like, you can even do this round as well. So if you don't want to have decimal values, you could say map range, and you could return round map range and put it at the end. And what this is going to do is it's going to round your values out. So you'll end up with a nice, straight, clean number that'll make your life a little bit easier to program through. So that's it. That's how you read any analog line sensor. And the map range value is quite easy. I mean, we could even change this up to between a range of 0 and 10. So now if I run it up, now I'm only getting, of course, these single digit values. You can give yourself 1,000 bits if you want to. You can give yourself 500 bits if you really wanted to. But again, you really want to choose a range that's easy to program with. And for my purposes, 100 is more than sufficient for giving myself lots of resolution to program with. All right, I hope you learned something new. Let me know if you have any more questions in the comments below. I'll try my best to help you out.